Continuing in your packet, here on this example, all kinds of stuff is going on. We don't even have real polynomials, but the trick that we kind of always look for is that idea where there's a donut hole whose derivative appears elsewhere. So I notice there's several sine x's, or a couple of sine x's floating around down here. The derivative of sine x is cosine x, which is great. That tells me that u substitution is a good idea. It also tells me that u equals sine x is a good idea, because then dx is du over u prime, and that u prime is perfectly going to take care of that numerator. So here, that numerator cancels with this, and so we're actually just integrating 1 over sine squared x is u squared minus u minus 12 du. And then it looks like a polynomial. In fact, now it is a polynomial, and it's a polynomial whose denominator is factorable. This is a u minus 4 and a u plus 3. The fact that the degrees are off by 2, on the quiz you would have gone for inverse trig for something like that, but again, now you're always going to look for factorable denominators, and if your denominator is factorable, factor it and do partial fractions. So that means we have some constant over u minus 4 plus some constant over u plus 3 needs to equal that numerator, which is just 1 over that common denominator. The fact that they're u's rather than x's is not a big deal at all. We're using that to help us integrate, and then we'll go back and substitute at the end. So we have that constant a needs to be multiplied by u plus 3. B will get multiplied by u minus 4. So that gives me the numerator. It needs to equal the other numerator because our denominators are identical. And so then again, Heaviside method or the system of equations thing here, I did system of equations last time, I'll do Heaviside this time. Also, no fractions are going to get involved, so Heaviside I personally think is a better choice anyway. If I let u equal negative 3, then my a term cancels out, but then I have a b times negative 7 equals 1, so b is negative 1/7. If I let u equal positive 4, then a times 7 plus b times 0 equals 1. So a is 1/7. So the thing that I had written up here in red can be written as two separate integrals, both with u's rather than x's, and again, that's totally fine. And the fact that these constants are fractions themselves isn't going to make a big difference. I'm going to do a fraction within a fraction thing. So my a, the 1/7, goes over a u minus 4. My b, the negative 1/7, goes over a u plus 3. And for us, you've probably started to notice a pattern at this point. Since we only do the simplest form of partial fractions, at this point it's always going to work exactly the same. If there were exponents involved down here, our splitting up might be a little different, the process we use to integrate might be a little different, but with what we're required to do, it's always going to work the same. My constant multiple comes out, there's a natural log in there, u minus 4, and you could say I'm doing like mental, I guess, v substitution. U minus 4 has a constant derivative of 1, so I could put a 1 over 1 in front to counteract it, or just leave it. The next one, I'll bring that negative 1/7 out. Here again, it's a natural log, u plus 3. That has a constant derivative, just 1. Mental u substitution, no big deal. And so from there, I'm just going to go back and substitute what u was standing in for. So I have 1/7 natural log sine x minus 4, just because that's what we had chosen as u at the very, very beginning, minus 1/7 natural log of sine x plus 3 plus c. For free response, this answer is completely fine. If this were multiple choice, I have a feeling it wouldn't be written in this way. because here, some properties of logs make this really simple because our coefficients are practically the same. So again, this answer is totally fine, but just to practice the properties of logs you'd be likely to see, let's do that. Since they both have a 1/7, I'm going to factor that out. So that leaves me with this, and then I'm subtracting the other natural log. And I'm just going to leave that plus c as its own little thing. And with natural logs, one of the properties, as you'll recall, tells me if I'm subtracting two natural logs, that's the same as dividing within a single natural log. So I can make it's an absolute value divided by an absolute value, so it's the absolute value of the quotient. So sine x minus 4 on top, sine x plus 3 on bottom, that 1/7 in front, plus c. If this were multiple choice, that's probably how I would expect it to be written, but there is also the trick where a coefficient in front can become an exponent inside, so it would also be correct to put that 1/7 as an exponent inside of the natural log. And it actually could go inside or outside the absolute values. It's an odd root, it doesn't make a difference. This, just for problems I've seen, I don't typically see them use that property, but it's still correct. If this were a multiple choice question on an AP exam, this red one would be what I would anticipate the answer choice would look like. I want to take a look at just a couple more quick examples. That takes care of the packet. So for this question, you might notice at first glance, and of course we've been doing partial fractions all day, the denominator is factorable as x times the quantity x plus 2. And so you might want to go ahead and do partial fractions, a over x and b over x plus 2. However, if you were to do that, you would run into all kinds of difficulties because you wouldn't be able to get this x cubed thing to happen. It would just cause all kinds of issues. And the reason for that is based on the degrees. If you look back at your flow chart, you don't look for a factorable denominator until you've done long division, if it's possible. Here, and really always, one of the first things you need to look for, I guess you could say the first thing you need to look for, the degree of the numerator is bigger. We need to address that before we start integrating stuff. So for this, I'm actually going to pause the recording just so you don't have to like stare at me writing all this out. I would pause, if I were you, I would pause the video as well. Try this problem on your own, and when you're finished, go ahead and hit play, and all of my work will appear all at once, and you can kind of pause and scroll through as you wish. Here you can see the result of long division, and so part of this is going to be easy to integrate, the x plus 3. And then the leftover quotient, this remainder part at the end, we're going to integrate that as its own thing, and that's where the partial fractions come into play. So again, I'm going to pause so you don't have to watch me do all the work. I would pause if I were you and try it on my own paper. Here you can see the result of the partial fraction decomposition on that remainder portion. And so now I've split it up into three pretty simple things to integrate. Again, you can hit pause and try to finish it up, or just play through, but I'm going to pause and do the rest of my work. And here's the final result of that process, both in kind of the easiest to achieve form, and then also, just like in the previous example, because we had a positive 2 here, a negative 2 there, I factored out the 2 and combined that into a single log. If it were multiple choice, I'd expect to see the red, but if it's not multiple choice, you can just stick with the orange and be done with it. And then I want to do one more, kind of the same way, just as a practice problem for you. Once again, if I were you, I would just pause this and try it. I'm going to pause and just kind of let my work show up a little bit at a time. That donut hole whose derivative appeared elsewhere, so that tipped me off to do u substitution. And then I was left with a polynomial denominator with u's that was factorable, and so I'm going to do partial fractions next. Here's the result of partial fraction decomposition, and at this point it'll be some mental v substitution before we get to a final answer. result of that process is here. Just something to be aware of that I've highlighted here. This 1 minus u has a derivative of -1, and so we need another negative in front to counteract that, which is how I ended up with division in my simplified answer. Here again, if this is free response, I don't care how simplified it is, this answer is fine. If it's multiple choice, I have a feeling it would look like this, that simplified one where you've used properties of logs. But with that, that finishes it up for partial fractions. Here again in Calc BC, we only do the non-repeated linear versions or linear factors, which is a heck of a lot easier, and they all just kind of work the same. So you can try some problems on your own at this point, and hope that the trial I'm in goes quickly. So, and that justice is served. That's more important, but also I would like to get back to teaching. So anyway, that takes care of it. Have a great day. Bye, guys.